Alright guys, this is our first lesson, lesson 1 of our brand new unit 6. In this unit we're going to be simplifying expressions involving exponents. We're going to be doing a lot of stuff with exponents. And basically what this is saying here is that when we're doing repeatedly multiplying or dividing by the same quantity, that is represented by exponents. So that's what exponents mean when you're multiplying by the exact same thing repeatedly. So for exercise 1, you should be able to do most of this all yourself. So I want you to do parts A through F, the entire exercise 1, on your own. So hit pause and give that a try now, please. Alright, so for part A, it said we want to make this as an extended product, and you did not have to evaluate it, so all you had to do is something like this. So hopefully you know 6 to the third means 6 times 6 times 6. Exactly the definition of an exponent right there, repeated multiplication. Part B, you should know how this is function notation. You're plugging in input of 1 and trying to get it out. So you should have set it up like this. I obviously did more work than you probably did, but you should know that negative 1 to the third means that, and you should know how to do negative 1 times negative 1 times negative 1. And finally, when you're done, you get something like f of negative 1 is 5. All right, let's take a look at the next ones. So this one said write this in some form x of n, and you're trying to figure out what the value of n is. And it says you could extend it if you needed to. So what I did is, just so you understand, hopefully you remember this rule, we did talk about it. But x to the third, you know, means x, 3 x's. X to the fifth means there's 5, so that would be a total of x to, whoop, I'm down here, x to the 8th. So that's extended way, long way of doing it. But maybe you notice you could just add these amounts and add these amounts and get x to the 8th. So there is an exponent rule that says if you have something like here, you can just add the exponents and get x to the 8th. So what I want you guys to do is get a separate piece of paper, an index card, something that you're going to keep. So hit pause and go get something like that, because we're going to write some stuff down that's important. Okay, so with this piece of paper, I want you to always keep these with your notes, because there's some exponent rules you really should have on hand, and they're not really written in these notes. So our first rule that we should talk about is when we're multiplying two numbers that have the same base, what we do with their exponents is, we just learned, you could just add those. So again, if we're multiplying, you simply add the exponents, and that's what that would be. So that's our first rule. Alright, so let's go back to our notes here, and now we can just use that rule from now on. For part D, really what this means, 5x to the third squared, it means we have this whole parentheses is being multiplied by itself. So that's what it would mean there, because there's two of those. Then we could use our old properties like associative and commutative property and move things around. And I just put the 5s with the 5s and the x to the thirds. And now we know that 5 times 5 is 25, and x to the third, we could use our rule and just add those and we get x to the 6th. So that was the answer there. But then it wanted you to take the values of a and b, so 25 is your a, and b, that would be your 9, and then you were supposed to add them, obviously, and get 34. Okay, and what I got down here? Oh, and then there's a quicker way we could do this too now, hopefully you could see, is that look at this x to the 6th. Where did that really come from? If we look at the original problem, we could learn a new rule right here. So what I did is, this is a faster way of doing it down here. I could kind of distribute, I want to say distribute, but I'm giving this square to the 5 and the x to the third, because I have to take the second power of everything in here. So this is 5 to the second power and x to the third to the second power. So I kind of distributed that power to each of these bases here. And there's a rule for this. Think about this. They're saying there's two groups of these, so there's two sets of 3. That means 2 times 3, and you could end up just multiplying those exponents, and you would get something like that. So here's another rule that you should know. So let's get out that rules paper again. So when you're taking we call this a power to a power rule. You're taking the power of a to the power of b, and what you would do to get your answer is you just multiply whatever these are, a times b. So there's a second rule you should know. Alright, and so again, you could do either way that I did. Let's get rid of that. There we go. Either way is fine. The red way was just a little faster. Once you learn these rules, it makes things a little quicker for you. Alright, let's keep going. Scientific notation. If you did one of our alternate lessons, you should have talked about this just a little. But this is something that you learned in 8th grade that you guys missed, so we got to make sure you understand scientific notation. First, you should know the area is length times width. So to find the area, you would have done the length of 3 times 10 to the 5th, and then 2 times 10 to the 4th. And then I could use my associative property and commutative property to group them up again. The whole numbers with the whole numbers, the powers of 10. Obviously, that would be 6 times, and then I could add my exponents right there with our exponent rule. Scientific notation is when you have a single number that's less than 10 greater than 1 times some power of 10. So this is really a really big number with 9 zeros after it. It's just a short way of writing really big numbers. All right. And here, problem F. Again, there was a long way you could have done this problem where you did all the work out. Now what I did is I used my rule, so I distributed the power of 2 to the 3 and the x squared. I see I can make a mistake right here. This is supposed to be x to the second right there. And then that will work fine. Sorry about that. And then hopefully, let's see if my work came out right. Yep, so therefore this, alright, sorry about that. I just realized I messed up my notes just a little. But hopefully that one makes sense now. I got the 3 squared, and then I multiplied the 2 times the 2 and got x to the 4th. And then over here, 2 to the 3rd is 8, and I multiplied those exponents. Then again, I would regroup some things. And you can see I regrouped those. Then I would obviously just multiply that out. And hopefully you got 72x to the 19th power there. So hopefully those went okay, because we're going to start doing a lot more with those. Okay, moving on to example number 2. Now, through these notes, they do it in a different way when it comes to dividing exponents than I would do. So I'm going to show you both ways, and you could choose which one you want. Kirk does this unmultiplying fractions, which is an okay way to do it. It takes some good understanding. It's a little more difficult, but I'll show you what he means. So he wants you to take this and split it into 2 different fractions. One fraction equals 1. And basically, you're trying to factor this out and see what I could take out of both of these. And they both have a 2x squared in common. I could do 2 times 1 and get the 2, and x squared times x to the 4th. So you have to be really good at factoring to do this method. And this fraction here actually equals 1 because anything over itself is 1. Now, this times what would get me that? So that's what I figured out at the top. So 2x squared times x to the 4th would get me 2x to the 6th. So I'm just breaking these up into factors. And 2x squared times what would get me the 4x squared? That would be there. So if I multiplied straight across, I would end up getting that. So 1 fraction equals 1, and that's the leftover. So to simplify that, that would be pretty easy because we know this came out to be 1. And then I have this left over. Remember, if there's no number in front of the x, you could put a 1 there. And then I could simplify it to 1/2 x to the 4th, or you could write it as simply x to the 4th over 2. Either way, those are fine. So that's how Kirk did his. And I'll show you how I do mine when we start doing these other problems. Alright, so basically we're going to learn how to divide exponents. This is a pretty easy process. Again, I'll show you how Kirk wanted to do it, where we would write this as a fraction that equals 1. So they both have 5 to the 3rd in common. And what would be left over is 5 to the 4th on the top. And you'd multiply across, and you'd end up with just 5 to the 4th like that. Alright, so that's the way Kirk does it. Let me show you what I would do. First of all, you need to understand that 5 to the 7th means, obviously, 5 multiplied 7 times. And 5 to the 3rd, I mean, there was 3 of them. And you guys should know that when we divide, 5 divided by 5 would just cancel out and become 1. This would cancel out and become 1. This would cancel out. And multiplying by 1 really doesn't change anything, so the only thing left is 4 copies of 5, which is 5 to the 4th. Now this is a long way of doing it, but hopefully you could see the connection here, that what did we do with those numbers? If you just end up subtracting those, you would get 5 to the 4th. So this is another exponent rule saying that when you're dividing same numbers, what you do is just subtract the exponents, and that would be your answer. So let's get our exponent rule sheet out again. And that comes to our 3rd rule right here. When you are dividing numbers with the same base, what you do with your exponents is just subtract them. So take whatever this one is and that one and subtract them. Pretty easy. So that makes things much quicker and easier for you. And we'll keep using that throughout here. Oh, next page. There we go. And again, so over here, I'll show you quickly what Kirk would have done is separated those, and you had to figure out this part, and you got 1 over x to the 6th. What I would have done is subtracted my exponents here. 4 minus 10, which actually gets negative 6. This brings up a new exponent rule. There is something dealing with negative exponents. So let's go back to our exponent rules sheet. And when you have a negative exponent, it's pretty simple. And remember, negative means opposite, so basically we're going to take the reciprocal of this. This just becomes 1 over a, but notice that a becomes positive, very important. So simply make a fraction and make the exponent positive. You can do the opposite too. So if the negative's on the bottom here, it's going to do the opposite and bring it straight up to the top like that. So these are the last exponent rules you need to know. All right, so let's use those now. Now that I have a negative exponent, I can use my exponent rules saying that this is going to turn it into a fraction, and the exponent is going to become positive, which is the exact same answer Kirk got up here. All right, last problem. And this one gets complicated if you try to use Kirk's method, but the one thing I would divide it into is these are the common factors of this whole thing, which you would multiply by this to complete that, and therefore your final answer would just be this thing here. So if you try to use the exponent rules, you could just subtract your exponent. So this would be, you could see the x's would be x to the 4, and that is x to the first power right there. So be careful that there's no exponent, that should be x to the first. And then it would be y, which would be 8 minus 10. I'd subtract those out. Notice I would get a negative exponent there, which basically we know turns it into a fraction like this. And if I multiply these across, I'd end up with the exact same thing. Now this looks complicated, but you'll get the hang of it. It's pretty easy once you get the hang of it. All right, let's keep going. Okay, so I'll just show you how to do these to save you a lot of time. Let's use our exponent rules and make things easier for us. So we should know how to do the top now. I'm distributing the power of 3 to the 3 and the x squared. All right, so that is for the top, and I would finish doing my work. 3 to the 3rd is 27. Multiply the exponents. There we go. This is left on the bottom. Now what I like to do is just break these into 2 separate fractions. So I just separate them like that. Now easily do this. 27 divided by 9, which is 3. We know to subtract these exponents here. And there we go. Okay, let's look at part B. Again, let's do all the work on the top. Distribute that power of 2 to everything. So be careful. And then we have to do the same thing on the bottom, distributing the power of 2 to everything. Okay, shh. All right, and I do the 5 squared, and get 25. Multiply exponents here, multiply exponents there. Same thing with the bottom, 10 squared. And then that would obviously be x squared and y squared. Then I would separate these into different fractions. Oh, I guess I just didn't separate them, but 25 over 100, you know, is 1/4. And then subtract the exponents there, which was x squared. Subtract the exponents there and get y squared. And y to the 4th, that's what I meant. There we go. All right, one last question. All right, so what he wants you to do is see if you can remember the different properties. So as these go from here to here to here to here, you're supposed to fill in a property. So see if you can do that. So hit pause and give that a try now. All right, let's see how you did. These are the properties that you should have filled in. Maybe. There we go. All right, so write those in, and that's it. And we'll give this some practice in class tomorrow.